Hello everyone, and welcome to the first section of Chapter 3, Solving Quadratic Equations. So this first section says match each quadratic function with its graph. Use what you know about when the parabola opens up or down. Also use the y-intercepts. Once you figure out which function matches which graph, look at the graph to determine the x-intercepts, if any, of each function or pair graphs, okay? So what I want you to do is try this on your own. I want you to stop the video, see if you can figure it out. I mean, just as an example, you should be able to look at A and say, well, that's got to be a parabola that's going up because this is a positive, where D has to be a parabola that's going down. You know that B has a y-intercept of 0, 1. Use all that information and see if you can figure them out. Okay, let's see how you did. So this first one is E, and then A, D, F, C, and B. And the way that I know that is A has to be going up. So right away, it's either got to be D, C, or E. But then, using the y-intercepts, I know that when x is 0, y is 0. Well, this one doesn't cross 0, 0. This one doesn't cross 0, 0. So that's how I knew it was E. And you can do that for all of them. So this one is also going up, but now we've already ruled out E. So it's either got to be D or C. And it has a y-intercept of 0 when x is 0, y is 1. So now I know it's D. Letter C is also going up, and there's only one left, but just to be sure, when x is 0, y is 2. So I want you to see how much you can tell from a graph just by knowing whether or not it goes up and down and what the y-intercept is. The next three have to be either A, because all three are going down, or F, or B. But notice their y-intercepts again. 0, 0. So which one goes through 0, 0? A does. This one is 0, negative 1. Where's that one? That's 0, negative 2. There's 0, negative 1 right there. So that one's going to be F. And then this one has a y-intercept of 0, negative 2. So that's how I figured them out. Now the directions did go back and ask you if you could find all the x-intercepts. So let's label those x-intercepts. I'll do them in green. So for this one, 0, 0, and 2, 0. Oh, this one has none. This one has none. This is going to be very easy. This one has 1. It looks like it crosses right at 1, 0. Letter E, and I've made some other marks on there. Let me erase them. This one also 1, 0. And this one looks like 0, 0, and 2, 0, which we actually had before, but this one's going up and that one's going down. Those are all the x-intercepts. So in this next section, I deleted the directions so I could fit it all on the same page, but it says, now look at each graph again and use the x-intercepts to find the real solutions of each quadratic function below. So the connection that I really want you to make today is when you're solving an equation, you're literally saying, what is the x that's going to produce 0? So if you can find this graph, negative x squared plus 2x, you can tell me when it's equal to 0. So where was negative x squared plus 2x? Let's go back and actually label them. So A was negative x squared plus 2x. And we decided that those intercepts were at 0, 0, and 2, 0. Those are the two numbers that are going to solve this equation. You already have this on your sheet, but I'm just going to fill it out real quick. B was negative x squared plus 2x minus 2. C was x squared minus 2x plus 2. D was x squared minus 2x plus 1. E was x squared minus 2x. And F was negative x squared plus 2x minus 2. So now when somebody says to you, when is negative x squared plus 2x minus 2 equal to 0? You can literally find that one and say, oh, that one's, I don't even need to do any work. That one's never equal to 0. For letter C, where's this graph? Where is this going to be equal to 0? I find it right there, and it's never going to be equal to 0. For part D, x squared minus 2x plus 1, where is that? Right there. Where is that equal to 0? Just in one spot. Letter E, right there, is going to be 0, 0, and 2, 0. And then the last one, F goes with, where is it? Oop, with F. So this one should have been minus 1 right here. And this one, again, just at 1, 0. So my point is, we're going to do these today algebraically. We're going to sit there and take this equation, and we're going to factor it. So I take out the x minus 2 is equal to 0. Either x is equal to 0, that's the first factor, or x minus 2 is equal to 0. That's the second factor. So my two answers are 0, and if I add 2 to both sides, 2. Those are my two answers. But I want you to see that algebraically, when you're solving an equation, you're literally finding the x-intercepts. Solving and x-intercepts, they're connected. And that's going to be one of the main goals, not just for today, but for this course, is to see how graphs and algebra are related. Okay, so the next section has 14 word problems. If we were actually in school, I would put you into your groups and I would say, figure these out. I would not do them for you. And because of that, I've written all the answers on here because I think that there are some of you that realize you will benefit from doing as many of these as you can on your own. So you can screenshot this page. I'm about to go to the next one. You can screenshot this page of answers. You can screenshot this page of answers. And now I'm going to go back and do them. So here's my general philosophy. If the equation has no x term, so this has an x term, this has an x term, ooh, number 5, no x term, then you can solve using square roots. So that means you can literally just get the x squared all by itself and then take the square root of both sides. Now in this case, can we take the square root of a negative number? No, you can't take the square root of a negative number. So this one has no solution. Let's see if we can find another one that has no x term. Ooh, this one has no x term. So I'm going to add 31 to both sides. You're in honors. You don't need to show this step anymore, unless you can't do the math in your head. 80, divide by 4. Again, you don't need to show that step. You can just show the next step. And then x is equal to taking the square root of both sides, plus or minus. So this is going to be an easy way to lose a lot of points. There are two things that make a perfect square. So if you have x squared is equal to 9, x could be 3 because 3 squared is equal to 9, or x could be negative 3 because negative 3 squared is also equal to 9. So whenever you start with x squared, there's always going to be two answers. So don't forget that plus or minus. If you only have one of the answers on a new problem, You're only going to get half the credit because you only have half the answers. So when you're doing the square root of 20, you need to break this down into parts you can do and parts you can't do. So I look at a number like 20 and say, well, the perfect squares are 1, 4, 9, 16, 20. Okay, I don't even need to keep going, right? 25 is already bigger than my number. Do any of these numbers go into 20? Sure, the 4 does. So I can break the square root of 20 down into the square root of 4 times the square root of 5. And the square root of 4 is 2, and the square root of 5 can't be done. Like I said, parts you can do and parts you can't. And those are the two answers. If the equation has an x term, your main goal is going to set the equation equal to 0 and factor. That's what you're going to be doing throughout the next couple years, 90% of the time. Now, of course, it's possible that an equation is not factorable, but we don't know how to do that skill yet. You might remember from Algebra 1, which is fantastic. Go for it. But you can use the graph to solve until we learn another method. Okay, so for the most part, when it's not without an x term, you're mainly going to set it equal to 0, which this one already is, and factor. The first times the first makes the first. The last times the last makes the last. Now, in that spot, I can put 1 and 6 or 3 and 2. Whenever you're trying to decide, start with the numbers that are closest together. So I'm going to start with the 3 and the 2. And then the inners and the outers always have to add up to the middle term. So I'm trying to get a negative x. They're adding up to that middle term. How could I do that? If the 3 was negative and the 2 was positive. So I'm going to make the 3 negative and the 2 positive. And then the last times the last still makes the last. Negative 3 times positive 2. That works. So if you're not very good at factoring, it's going to be all over the place. Got to know it. All right. And then my final answer on this one, either x minus 3 is equal to 0 or x plus 2 is equal to 0. So x is equal to 3 or negative 2. That is not what I wrote over here. Let's see why. Did I factor that wrong? Oh, no, I just wrote the answer wrong. Oop, poor somebody that screenshotted the answers. Yeah, I just wrote it wrong. Yeah, it is 3 and negative 2. Okay, when you're setting something equal to 0, first of all, I see an x term, so I know I have to set it equal to 0 and factor. Always factor out first. Look for anything they have in common. So they all have a negative 2. So not only do I factor out, but I always factor out to make the first term positive. It is so much easier to factor if the first term is positive. So I'm going to take out the negative for sure to make the first term positive, but it turns out I can take out a 2 as well. X squared plus 2x plus 1. Make sure you keep writing that negative 2. It's still part of the problem. I will take off points if you don't. And then again, the first times the first makes the first. And I love this. The last and the last, there's only one choice. 1 and 1. The inners make 1x, and the outers make 1x, which adds up to 2x, which is just what I want, so I know that they can both be positive. Make sure you keep writing your equal to 0. Notation matters to me. I will take off points if your work is not consistent in every step. So this is a little bit of a warning here. Sometimes kids give me the answer x is equal to 0. That would be wrong. There's 3 factors. Either negative 2 is equal to 0, or x plus 1 is equal to 0, or x plus 1 is equal to 0. One of these 3 things has to be equal to 0 to make 0 as an answer. My good news for you, it's not this one. Okay? So don't change it to x is equal to 0. If x is 0, you'll just get negative 2 times 1 times 1, which is not 0. But if x is negative 1, Can you guys see how that would make a 0? You'd have -2 times 0 times 0. That would make 0. So that's one of the answers. Now, if you get two identical factors like we did here, you don't have to write it twice. Okay, you don't have to write and -1. It's just the same answer. And that happens. What does that mean graphically? So graphically, what's happened is the parabola doesn't go through -1 and then up somewhere else. It can't. There's no other 0. So when you have a repeated factor, x is equal to -1 twice, graphically, that always means that the graph bounces. So x is equal to -1 represents a bounce graphically. Boom, like that. Okay. Number 6, you might be becoming more confident and want to try one on your own. I encourage you to do so. I see the x term, so I know that my process is going to be to set it equal to 0 and factor. There's only one way to factor 3x squared, 3x and x. And while there's only one way to do the 2 and 1, it could be 1 and 2. You could reverse the 2 and the 1. So we are going to have to play around with it to figure out which one is better. So let's put 2 here and 1 here. My inners are 2x. My outers are 3x. And at first you might think, oh, that's perfect. I need a -5x. I'll make them both negative, and that gives me a -5x. But your last times your last doesn't make your last. -2 times -1 is +2. So even though this looked like it worked, it doesn't, and you have to be really careful. I actually just had somebody in calculus that made that mistake. They said, I factored wrong. I know, it's hard work. It is going to be this. The inners are 1x, the outers are -6x, and that makes a -5x in the middle. Don't keep those loops there, it's just for me to factor correctly. The bottom line is there's no excuse for factoring wrong. You can remultiply first, outer, inner, last. It's got to work every time. So either 3x plus 1 is equal to 0, or x minus 2 is equal to 0. Again, the reason for that, if you have 14, I have no idea where that box came from. If you have 14 times something is equal to 0, what must go there? It must be 0. But even if you didn't know the first number, if you just had something times something is equal to 0, then one of those two somethings must be 0. That's where this comes from. It actually has a name, the zero product property. So again, you're not required to show -1 and -1 anymore, but you still should show enough steps that if you make a mistake, I can find your mistake for you. The two answers are -1/3 and 2. I'm just going to keep plugging away, but by all means, you can stop the video anytime and do your own thing. This one's already equal to 0. How lovely. So I'm going to factor. My only choices are x and x. 35 is 1 and 35 or 7 and 5. I'm going to choose 7 and 5. That gives me 7x and 5x, which would give me 12x if they were both positive. Can they both be positive? Yes, that would make a positive 35. So I feel good about my factoring. Either x plus 7 is equal to 0 or x plus 5 is equal to 0. So x is equal to -7 or -5. All right, number 7's a little trickier. So I consider this to be in this category. Even if you have x plus a number squared is equal to a number, that's still the category where it's missing an x term. It really just has the x squared term. And this is fantastic when you can use this. I would do not expand. It's going to be so much work to expand, meaning multiply it out. So instead, People really struggle with this fraction thing. So consider this a fraction times a whole number. Let's make it a fraction times a fraction by putting it over 1. And then you can go straight across the top and straight across the bottom. And now kids are usually more successful in finishing it. So I'm going to multiply both sides by 5 to clear my fraction. And I get 2x plus 3 squared is equal to 25. And then I get x plus 3 squared is equal to 25 over 2. So if you can ever get a quantity squared, that's the same as just getting an x squared. You still are going to square root both sides. So I'm going to take my x plus 3 squared and my 25 halves, and I'm going to square root both sides. Don't forget that whenever you square root both sides, you're going to have a plus or a minus. There's 2 answers. Now the top I can do. The square root of 25 is 5, but the bottom I can't. So I'm stuck with a square root of 2 down there in the bottom. I'm going to subtract 3 from both sides, and that gives me -3 plus or minus this 5 over the square root of 2. Now you may remember that you're not allowed to leave a square root on the bottom. So if this happens, you're going to have to multiply the top by the square root of 2 and the bottom by the square root of 2 in order to get that square root out of the bottom. That gives you -3 plus or minus 5 square roots of 2. And do you see why we did it? The square root of 2 times the square root of 2 is the square root of 4, which is just 2. You don't need to show that because it's always going to work out. Hardest one, I think. But worth knowing. It's worth, when you see this configuration, think of it just like having an x squared and no x term. When you see this configuration, just get the square thing all by itself and then square root both sides. All right, we're going to follow that with a somewhat easier one. It's already equal to 0. I can go straight to my factoring step. The first times the first makes the first. 12 has a bunch of choices. 1 and 12, 2 and 6, 3 and 4. I always tell kids to start with the middle 2 first, unless you can see that those aren't the ones. I look at 2 and 6 and I'm like, 2 and 6 make 8. I'm totally picking that. So -2x and -6x would give me -8x, and the last times the last, the negative times the negative makes the positive. No excuses for not getting FOIL because you can, not getting the factoring, because you can always FOIL it to check. Make sure you have your equal to 0. Keep your notation good. Remember, I'm here to make you math champions. When I first started working, I worked with a teacher that was so strict. All the answers had to be in number line order. So you couldn't write like -3 and -10 because -10 is smaller. Or you couldn't write 1, -2, and 5. Had to be in order. So there are even stricter teachers than me out there. X is equal to 2 or X is equal to 6. So notice I'm not very fussy about how you give me the answer. You can do plus or minus. You can write the word or. You can write them separate. I think on this page, I didn't even box the X on one of them. I think I just boxed the answer. That's fine. So just get me the right answer. Set it equal to 0 and factor. Okay, these are the last 6. If you haven't tried any on your own, you might want to do that, but I am going to keep doing them. I see another one with no X term. When that happens, you can literally just subtract 1 from both sides, divide both sides by 2, and take the square root. So X is equal to, I'm going to do the square root of both sides, which gives me plus or minus. Don't forget, you'll only get half credit on a problem because you're only going to have half the answers. So it might be easier to write this as the square root of 7 over the square root of 2 separately. And then just like before, I'm going to multiply the top and the bottom by the square root of 2 because I'm not allowed to leave the square root of 2 in the denominator. That gives me the square root of 14 on the top. 7 times 2 is 14. They're both under the radical. And the 2 is no longer under a radical. The square root of 2 times the square root of 2 is the square root of 4, which is 2. That's always going to work out. So on number 10, I personally think you should always clear fractions first. There's two ways to do it. The way, if you're struggling, is to change it so that they all have the same denominator. This works out really well for kids that struggle with fractions. And then you can see that if you multiply both sides by 2, that you're going to get x squared plus 12x, because when you multiply by 2 and it's being divided by 2, it goes away. Oops, equals minus 40. You're welcome to do that. I will not be doing that this year. When I have a fraction, I'm going to jump straight to multiplying by the least common denominator, which is 2. So on this side, 2 times 1/2, straight across the top, straight across the bottom. So that will give me just x squared. That's why I chose 2, so that the fraction would go away. And when I distribute the 2 on this side, I get 12x minus 40. I see an x squared, so I think I'm going to set equal to 0 and factor. And there's an x term, so that is my strategy. You might be tempted to move the x squared over, only move one thing instead of moving two things. But I personally think factoring is easier when the first term is positive. The first times the first makes x squared. And there's a lot of choices for 40. 1 and 40, 2 and 20, 4 and 10. I can't even, that's it, right? Oh, no. 5 and 8. Okay. But none of those add up to 12. So it can't be factored. So then the question is, how do I solve it? Well, in chapter 3, we are going to learn how to use the quadratic formula. So I do want you to write that down. If you can't factor, use the quadratic formula. But you haven't learned it yet. So we're going to do something different, or graph. We're going to go ahead and graph it. So your first step to graph it would be to hit y is equal to on your graphing calculator. If you have things left there from other days, you can hit clear and then down and then clear. And I usually go back up and plot it on y1. So here's your x button right next to your green key. And then for squared, if you can use caret and then 2, but I just hit squared and it does it right away. Minus, careful not to use the negative key next to the enter, 12x plus 40. My goal is to figure out when this is equal to 0. So since right now it's equal to y, I'm going to be looking at the x-intercepts. I want to know where it's equal to 0. Oh yeah, I had mine way zoomed in for something. So I'm going to hit zoom 6. That's the one that restores it. Right away. Can you see what happens? No solution. This graph doesn't come anywhere near the x-axis. So right here, y is equal to 0, but y is never going to be equal to 0. For number 11, again, this is one of those special ones where I see a whole quantity squared. I'm going to treat it just like having an x squared and get the quantity alone and then take the square root of both sides. So I'm going to divide by 2. I get x minus 2 squared is equal to negative 5/2. I take the square root of both sides, which gives me x minus 2 on this side. Don't forget your plus or minus. But then I see I have a negative under the radical. Am I allowed to have a negative underneath the radical? No. So this one I know algebraically is going to be no solution. Now, just because, I teach math, I have to show you everything. Think about this. If you had set it equal to 0 and you couldn't solve it and you wanted to know graphically what it looked like, you guys know what this looks like. It's been moved to the right 4 and up 5, and it's an upward parabola. So that's why it has no solution. It's never going to cross the axis. Number 12. Number 12 is already equal to 0, and there is an x term, so I'm going to jump straight to factoring. I do like to look to see if there's anything that I can factor out, but this is a 4 and that's a 9. They have nothing in common. This could be 4 and 1, but I would start with 2 and 2. And if it doesn't work, I'll switch to 4 and 1. And this could be 9 and 1, but it also could be 3 and 3, and I just think it's better to start with the ones that are closest together. You've got the highest probability of getting it right when you start with the ones that are closer together. That gives me 6x and 6x. I'm trying to get a negative 12x, which I could do if these were both negative. For those to be negative, these would have to be negative. And a negative 3 times a negative 3 does make a positive 9, so I feel good that I factored correctly. No excuse for getting factoring wrong. Equals 0. My factors are identical, so I only need to do one of them. 2x minus 3 is equal to 0. 2x is equal to 3. X is equal to 3 halves. There's only one answer. Do you remember what that means graphically? It means that at 1.5, there's a bounce. And since I can see that the y-intercept is 9, I actually can make a pretty nice graph. All right, what do you see in number 13? Fraction. Fraction alert. Fraction alert. Get rid of it. Multiply everything by 3. 3 times 2/3 is going to be 6/3, which is 2. But I don't want you to think about it that way. I just want you to say the 3's cancel. That's why you multiplied by 3. So it's going to be 2x squared. 3 times 14 is 42, and 3 times 20 is 60. 2x squared is equal to 18. X squared is equal to 9. X is equal to 3. No, plus or minus. Don't do that. So this is a lot of steps. If that last step is wrong, you're only getting half the credit because you only have half the answers. Don't forget your plus or minus. The next one, I see the x term, so I am going to have to set it equal to 0 and factor. That gives me x and x. 45 is 3 and 15. Is that right? Yep. Or 1 and 45. Or 9 and 5. All right, so even though there's several choices, I choose the two numbers that are the closest together first. And that gives me 9x and 5x. And I'm trying to get a negative 4x. So to get a negative 4x, the 9 would have to be negative and the 5 would have to be positive. So to make these two make a negative 9x, this would have to be negative and this would have to be positive. And then the last times the last does make a negative 45, so I can feel good about the factoring. No excuses for factoring wrong. Equals 0, don't forget, nice format there. Or x plus 5 is equal to 0. And my two answers are 9 and negative 5. All right, I don't know how many of those you did on your own or how many you watched, but I hope after 14 examples you thoroughly understand it. So the solutions, this is what we've been saying the whole time, to a quadratic equation are also the x-intercepts. I know you're thinking, you already said that. I know. I'm going to keep saying it until everybody gets it. Another name for the x-intercepts are zeros. So I guess somebody got tired of calling them x-intercepts, kind of a mouthful. So a lot of people refer to them as zeros. So when it says find the zeros, that's really just the x-intercepts. Okay, so in other words, we're still going back to what we've been doing. Set it equal to 0 and factor. This has no third term, but you can factor out. That stands for factor out first. FOF, factor out first. So I take out the x and I get x minus 8. So there's two factors, either x is 0 or x minus 8 is 0. X is equal to 0 or 8. So how does that help me make a really quick sketch? I know that it has an x-intercept at 0, meaning this is y, right? So y is going to be 0 if x is 0. Y is going to be 0 if x is 8. And I know it's an upward parabola because this is positive. So I know it looks something like this. I did not find the vertex. It just wants a quick sketch using the x-intercepts and the y-intercept, but we already had that. Number 16, I set it equal to 0. That's how you find an x-intercept. Let y be equal to 0. Because at this moment, y is always going to be 0. When you're on the axis, the y coordinate is 0. So I'm going to let y be 0. 2x squared minus 11x plus 12. Now this has to be 2 and 1. That's the only way to factor it. But the 12 has lots of choices. 1 and 12, 2 and 6, 3 and 4. I personally always start with the two that are closest together. So 3 and 4. And I might have to reverse it, 4 and 3, because one of them is going to get affected by that 2. So 3x are my inners, 8x are my outers. Woohoo, I'm trying to get an 11x. If I make them both negative, not only does the last times the last still make 12, but I got it, okay? Putting the numbers closest together, 9 times out of 10, it's going to work. So either 2x minus 3 is equal to 0, or x minus 4 is equal to 0. So my two answers are 3/2 or 4. How can I graph that? 4 and 3/2, which is 1.5. But it did say to use the y-intercept as well. So way up here, when x is 0, so just like x-intercepts make the y 0, 3/2 means y is 0. X-intercept means y-intercept means x is 0. And when x is 0, it's really easy to plug in. You get 12. That's my quick sketch. Tried to make it look big, even though I didn't actually count those spaces, but 0, 12. It's just a sketch. If I say graph, I want something nice. But if I say sketch, I'm just trying to get you guys to follow. Oh, and it makes sense that it's steep, right? Because look, it's got a 2 in front. Ooh, this one's going to be really steep, which makes sense. Its y-intercept is going to be 49. All right, let's find so y-intercept is 0.49. Okay. All right, let's find the x-intercepts. 4x squared plus 28x plus 49. I can't take anything out. 4 and 49, I have nothing in common. So I do always try 2 and 2 first. And with 49, you got a choice between 1 and 49 or 7 and 7. I'm going to go with the 7 and 7. That gives me inners are 14x and outers are 14x. So if I make them both plus, I get my 28x. That worked out great. So let's see if you guys remember what this does. If both of them are repeated, what does that look like graphically? It means that there's a bounce. So 3.5 is right there. If you went through it, you'd have to come up somewhere else. But there is no other place to come up. There's only the one x-intercept. So instead, when it repeats, it's always going to mean a bounce. And then way up at 0.49, obviously this is not a great graph. It's so bad I'm actually just going to erase it because I forgot that I have to get all the way up to 49. So 3.5 and 49 and a bounce. Okay, that was a terrible bounce. The whole point is to not go through. Bounce. There you go. So there's my 0.49. There's my bounce at -3.5. And there's my quick sketch, which I did happen to find the vertex in this case, but you're not required to. Great. You guys are doing great. Thanks for hanging in there. All right. What do we got? Ooh, 2 word problems. Let's do them. A skydiver drops out of an airplane that is flying at an altitude of 4,624 feet. Using the formula, now I think you're actually going to need this formula in your homework too. This is not just any formula. This is the formula for a free fall. To write an equation that gives the skydiver's height during the free fall 10 seconds after the skydiver drops out of the airplane. So his drop is vertical, right? So you've got this airplane and you've got this guy dropping out of it, right? His drop is straight down. But this equation tells us his height as time goes by. So why does it look like that if he's falling straight? Because it's telling you the different intervals. So at 1 second, he's here. At 2 seconds, he's here. At 3 seconds, he's here. And why is it parabolic? Because he's not falling that fast when he first starts to fall. But now he's falling a little faster, right? Like he, in that same interval of time, he only dropped this far, and now he's dropped this far, and now he's dropped this far. He's speeding up. He's going faster until he hits the, parachute. So this will tell you his height at any time. So his height at any time, his original, this little O means original height. So plus 4,624. So that's what varies. People might jump off of a bridge or for bungee jumping or something like that. This is where you would put the original height. But this 16 never changes. That's the number that's due to gravity. So what do they want to know? Use the formulas to write an equation. Oh, we did it. That's it. That's all they wanted. Is it possible for the skydiver to wait 18 seconds? Ooh, let's see what his height is going to be after 18 seconds. 16 times 18 squared plus 4,624. I would say get out, if you were in class, I'd be looking around and forcing you to get out your calculator to do this with me. But, I know you're just sitting there in your bedroom waiting for me to do it. I'm doing all the work. And I get, -560. What does that mean? That means his height is below ground, okay? So no, after 18 seconds, his height, so I'm going to change this to a more accurate way of writing it. His height after 18 seconds is down in the ground. He's negative, so he's already hit the ground. He cannot wait 18 seconds before pulling the parachute cord. What if you want to know how many seconds will he hit the ground? That would answer the question, or you could answer that question by saying 0 is equal to -16t squared plus 4. So in case that was your thought for doing it was, oh, well, let me find out when he hits the ground, then you would have had 16t squared is equal to 4,624, which is t squared is equal to 289. Now, normally I've been making a big deal about the whole plus or minus. but our t, our domain, is t is greater than 0, so I don't need the minus, okay? It's just going to be t is plus 17. So he actually hits it 17 seconds. So after 17 seconds, it's too late. All right, last one. This one actually, I'm just going to give you a little hint that it is definitely going to be on a quiz or on the test. And there are no points for guessing and checking. I want you to algebraically know how to do this problem. It is for some reason considered just a really hard problem for kids. It's not. It just requires more thought and less formula. But if you think it through, it makes a lot of sense. All right, a monthly teen magazine has 48,000 subscribers when it charges $20 per annual subscription. For each dollar increase in price, they lose about 2,000 people. How much should they charge to maximize their annual revenue? So the first thing that you need to know is how revenue is calculated. So you're going to get revenue from the number of people who buy it, called subscribers, times the price they pay. That's how revenue is determined. So right now, they have 48,000 subscribers, and they're paying $20. So 48,000 times 20 is $960,000 they're making. But their question is, if we charge $21, we would lose some customers, but the rest of them would be paying more. We would make a lot of money. So how do they figure that out? This is why they do studies and things, and they look at internet pricing, and they're able to figure out what the best amount is. And they've decided that when they tried to raise their price $1, they lost about 2,000 people. But maybe they don't care about those 2,000 people. They want the money. So we're going to write an equation. Now, this is what makes this equation so tricky, is I'm going to let x, this is the tricky part, x is equal to the number of times they raise the price. So if they raise the price x times, each time they're going to lose 2,000 people. So they're going to lose 2,000 people each time they raise the price. So if x is 1, they're going to lose 2,000 people. If x is 2, they raise the price another $1, they're going to lose 4,000 people. This is the step that's so hard for people. And what happens to the price? Well, it was 20, but each time it goes up, it's a $1 increase. So if they raise the price twice, this will be a $2 increase. If they raise the price 3 times, if x is 3, it'll be a $3 increase. This is your equation. What shape is it? It's in factored form, it's in intercept form, and it's a parabola, because see the x and the x? And if you multiplied it out, it would be negative. So it's a downward parabola. So their question is, what is the maximum revenue? Well, do we know how to find a maximum? That maximum is negative b over 2a. If you have y is equal to ax squared plus bx plus c. If you already have it in factored form, does anybody remember a slightly easier way rather than multiplying it all out? You could find the two intercepts. So to find the first intercept, we'll do the easy one first. 20 plus x is equal to 0. X is equal to negative 20. The next one, 48,000 minus 2,000. X is equal to 0. So 48,000 is equal to 2,000. X divide by 2,000 and you get 24. So One is at negative 20 way over there, and the other, 20, and this one's at 24. So it's some huge thing. But where is our maximum going to be? Right down the center, which if you find the center between them will be x is equal to 2. How do you find the y value? You would plug it back into the equation. But don't forget, this is where people really get stuck. 2 is not the price of the magazine. 2 is not the number of subscribers. 2 is the number of times they raise the price. So if x is equal to 2, they were charging $20, and then they've raised the price $1, and then they've raised the price another $1. So the price is now going to be $22 for this magazine. They used to have 48,000 subscribers, but they're going to lose 2,000 twice, minus 2,000x. They're going to lose 4,000 people. They're going to have 44,000 customers. What is their maximum revenue? Well, there's two ways to find it. It is the y value. The maximum revenue happens if x is equal to 2. So you could just plug 2 into this equation, or since I've already done these two numbers when I was trying to explain it, 44,000 times 22, so the maximum revenue is, I wrote it down somewhere, $968,000. So do you remember how much it was in the beginning? Ooh, $960,000. So the point is this was what they were getting before, $960,000. By raising the price, they can get a little more revenue and a little more revenue, but what happened right there? If they raise it 3 times, if they raise the price to $3 higher, $23, they're going to lose so many subscribers, they won't be making as much money anymore. And that is what cost maximization is doing. If this makes a lot of sense to you and you're interested in this, this is what the business world needs, is mathematicians who can solve these kinds of problems. If you're still a little hesitant, then business math might not be for you yet. You're only a freshman in high school, so lots of time. All right, that is the end of section 3.1. Great job.